Okay. My first question to you today is, can a sample parameter be exactly the same as the population parameter? Why? Gladys?
Yes.
Yeah. Can a sample parameter be exactly the same as the population parameter?
Yes.
Your answer is a yes. Okay. Okay, Kavan said no. Okay, if Gladys, you say yes, can you tell me why?
Coincidentally the same.
Huh?
Coincidentally the same. If the sample you pick is having the same parameter to the whole population parameter.
Okay, usually in this chapter, what are the two parameters that we are talking about?
Mean and population proportion.
Yeah. So can the sample parameter be exactly the same as the population parameter, same parameter that we are talking about? If that is the case, if you say can, then I will ask you why yesterday we talk about sampling variability. So if sample parameter can be exactly the same as the population parameter, then I can just take one sample and settle the whole thing.
It can be same, but it's not always the same.
If you say can be the same, what is the chances of it to be the same? What is the chances that the sample parameter can be the same as the population parameter? What is the chances?
Not sure exactly.
Not sure exactly. I can tell you it's very, very unlikely. You see, yesterday I give you say a well-selected sample will still not produce a statistic that matches the parameter of the population exactly. So the answer is for this question is no. The answer for this question is can't. Because sample is just part of the population. Their parameter of interest will naturally, yesterday I tell you, be off a little from the population parameter. And that one we call it sampling variability. So if I ask you what is sampling variability? What is sampling variability? Next. Try.
The definition that you put just now.
The difference, correct?
Yeah.
So we call it sampling variability is the naturally occurring, it definitely will occur, occurring difference between a sampling statistic or a sample statistic and a population parameter. Or we call it sampling parameter also can. A population parameter. The difference of it. But the difference won't be big. Because it is part of the population. So it cannot have the exact value. It will vary a little bit. The chances of it to be exactly like the population parameter is almost zero. So you'll get some sample statistic whereby the value is a bit more than the population parameter. Some is a bit less than the population parameter. So that brings us to the idea, how are we going to recognize whether the sample that we take is biased or not? Okay, whether the sample that we take is biased or not. Okay, so the answer will be if a sample statistic is way far from the population parameter, it is attempting to measure, then the problem is a lot more than sampling variability. It's more than that already. So the sample doesn't represent the truth of the population. So it is called a biased sample. I mean, it doesn't give you the true picture of the whole population if the variation is very far. So there are a few reasons for biased sample. So when you talk about bias sample, it can be of many, depend on. Like for example, you all talk about, you all send out Google form. You all do your EAL, you send out Google form for people to answer question, correct? So I answer the question is depend on what I like. So this is called systematically favored responser. The favoritism of the responser. So that is talking about how you can get a bias sample. So everything when you say Google form, correct? You ask people to answer, correct? They can answer, they can answer, depend on my favorite. So if they can have favoritism come in. So that will create a bias sample. And another one is the way you select the sample. The method you use. Is it random or not? When you talk about survey, okay, you send out your Google form. Who do you send to? You send to your friend only? Or you send to anyone? Or you send to the friend that you like? All these are the chances of create bias sample. Like you ask people to respond voluntarily. So this is also a biased way of collecting a sample because you only attract those interested. Another way of collecting sample is convenience sample. I just simply go to a supermarket and I just go to that supermarket and collect the people talking about whatever you are talking about, convenient. And another bias sample will be under coverage. That means, like for example, you want to talk about people who are having high blood pressure at certain age. Do you cover those staying in outskirts? When you talk about using apps or Google Form or through your Facebook, not everyone have Facebook. So that is called under coverage. So there are a lot of things about how you can get a bias sample. So please go and look for it. Go and read about it. Okay. So that is the reason why we have to study whatever is in this chapter. Yeah. So we know that a sample statistic cannot represent the population parameter that you are interested in. So how are we going to use a sample statistic and based on a certain theorem and start to make a prediction of the population parameter? That is what we are going to learn from now onward. So please bear in mind, a sample statistic cannot represent the population parameter that you are interested in. Got me? So you have to do some prediction, some analysis based on a certain theorem and start to work on it. Okay, now I'm going to get into part A today, sampling distribution. Okay, can you please go to page 254? You please read through the whole thing first. Anything you don't understand, you ask me first. Then I'm going to explain the whole thing through example 1. Okay, so in this part of the question, you have to know that the meaning of this. Okay, what is the meaning of Sn? Is the sum of the n observation. Okay. So now, if you look at example 1, I have the population. Okay, in all the example here, we don't give you the population that is very big. If I give you the population that is very big, if you want to get all the exotic sample, then you will go crazy. It can go on and on. Okay, so now, I have two values of the variable, that is 3, 2, and 3. Okay, and the probability of getting a 3 is 1/3, and the probability of getting a 2 is 2/3. Okay, so now I'm looking for the another variable that is called S2. That means I pick a sample of 2 from this population and I find the sum of it. Okay, so what I can do is I have to build my probability distribution table of my S2. And this is the probability. So now if you look at it, it's exactly like in a box. You have 3 and 2. You pick one. Then you put it back again. You pick another one. Do you get me? So for this case, I will trick it like I have a dice of 2 faces. Impossible to have a dice of 2 faces, okay? So 3 plus 3, 2 plus 3, 3 plus 2, 2 plus 2. So, correct? So my S2 will have this value 4, 5, and 6. So probability of getting a 6 is equal to probability of getting a 3 and a 3. So when we talk about n, we multiply. Probability of getting a 3 is 1/3. Probability of getting another 3 is also 1/3. So I get 1/9. So this is 1/9. So probability of getting a 5, there are 2 different ways. So you add up. So you look at the book, you see that? You see that how they get all these numbers? Okay, so these are all the probability. And 4 also 4/9. Okay, so you understand how the book get it? Are you okay? Okay, so now I want you to listen. Usually after we get the probability distribution table, what we do? Okay, from this one, can you please take out your calculator, find the population mean? Can you tell me what is the population mean? And population standard deviation? And what is the sum of the S2? S2, I want the mean for S2. And I want the standard deviation for S2. Can you please key into your calculator, everyone, and get the answer? That is, I go into investigation area. Can you please? Go to stack, go to calculate one bar stack. Okay. Christopher, can I have the population mean?
I do the sample one only. I'm gonna do population now.
Okay, then you give me the sample one.
Mean is 4.666.
Okay. And the standard deviation?
0.666.
Okay, now you try to do the population.
The mean is 2.333.
Thank you. And the standard deviation?
0.471.
Okay. Thank you. Correct, everyone? Okay, so now you look, there is a relationship. Do you see some relationship between that? You see, if this one I times 2, I get this, am I right? How about this? I times square root of 2. Am I right? Hello? Yeah, so this is just one example, okay? For statistician, they have done many examples. So they come to a conclusion that the mean for the sum of Sn is equal to n times the mean of the population. The standard deviation of the Sn is equal to square root of n, the standard deviation of the population. So that is a very important formula that you and me must bear in mind. Are you okay? So that will help you. That will help you to do all the question in exercise 9A. Okay, we want to prove whether this question is correct or wrong by going through one of the question in your the activity, all that. Okay, so I think I'm not going to prove it. Yeah, so now everyone, you look at exercise 9A. Okay, you start doing exercise 9A now. So for this part, this is a very important formula that you have to remember. Okay, go to exercise 9A. And with the extension of it, can or not? Okay, for question 1, this is the population that I have. Okay, the probability is 1/4 and 3/4. Okay, so now if I want to build the probability distribution table for S2. Okay, so what I will get is, okay, will be 1, 2, 1, 2, sum plus. So I will have 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 1 plus 2, 3, and 2 plus 2, 4. So my answer will have a possible value for S is 2, 3, and 4. So the probability, you time by the probability. The probability for getting a 1 is 1 over 4, 1 over 4. So it will be 1 over 16. Probability of getting a 3 is, sorry, this is 3 over 4. Okay, 3 over 16 plus 3 over 16. So it's 6 over 16. And this one will be 9 over 16. You get me? So from there you can get. So now if from here, I want to have this distribution. So I want to hear from you. If I want to have S3. Okay, So now, when you have this situation, correct? I can't draw the chart anymore. So what should I do? So my one possible outcome was all the three is 1. So the sum will be 3. Or 1, 1, 2, 2. So in this case, there are a lot of outcomes. Okay, we list one by one first. Okay, 2, 1, 1, 2. Okay. So the probability of getting a 3 here will be equal to 1/64. If I get 1, 1, and 2, so the sum will be 4. So there are how many arrangements of this? I can have 1, 2, 1. So all these you come back again and 2, 1, 1. Am I right? Hello? So you can get a 4. You can also get many, many more. So for this case, you have to really list down. So during the exam, can we ask you about that? So it's up to the examiner. Do you get me? They can ask you to get the possible value for S3, but they won't ask you to find the mean or the one. They will ask you to find the mean of S3 by using this formula. Are you clear? So I'm just telling you, it's possible we may ask you to list out like that. So you can have 4. What else you can have? You can also have 1, 2, 2. So the possible value can be 5. I can also have 1, 1, 3. The possible value here is 5 also. Then I can have 2, 2, 2. So a lot. So you have to list out one by one. No other easier way. So I'm just letting you know there is a possibility of doing question come out in that way. Okay? So you have to really patiently do it. So I've done my part A. Okay. What are the possible value for S2? So you can have 1, 2, 3. One, 2, 3. So you add 2, 3, 4. 3, 4, 5. 4, 5, 6. So possible value for S2 will be 2, 3, 4, 5, 6. Then you build your probability distribution table. Right? S2 probability. Getting a 2 is both are 1. So half times half, you get 1/4. Probability of getting a 3 is a 2 and a 3. You got 2 different ways. So 1/4 times 1/4, then times 2. So 1/8. Are you okay? So probability of getting a 4, there are 3 of them. Is from different things. 1 and 3, 1 and 3. So it's half times 1/4. So there are 2 of them get from 1 and 3. So you times 2. So you get 1/4. Then another 4 is from 2 and 2. So 2 and 2 will be 1/4 times 1/4. So 1/16. So this is 4/16. So in total, 5/16. Are you clear? So getting a 5 and getting a 6. That is how you build. Are you okay? Getting a 5 is 2, 3, 3, 2. Okay. So this is also 1/8. Getting a 6 is 1/16. So you add up all the probability, you should get 1. Okay? So that is how you build your probability distribution table. Correct? So it's 1/4. You're right. Okay? So please complete that exercise. So for 9A, the important thing is this formula. Please remember. This one. Okay? Thank you, class.
Thank you, Miss.
Thank you,
Miss.
Miss.
Thank you.
Thank you, Miss.
Thank you.